Piotr Kafel, and I live in Berlin. I am software engineer in Groupon, and I guess this is all that you need to know actually about me. Because we are not here to talk about me or to talk about Groupon. What we are here to talk is confusion. And in our industry, I have a feeling, at least, that we love confusion. It's parts of our job, of our industry from the very beginning. I don't know how is it for you, but for me at least, when I'm thinking about one of the first confusions that come up to my mind when I was starting as a software developer, it was like if Java and JavaScript is the same. I know for some younger of us, it might be like strange that people were confusing those two languages. But back in the days, that was really a thing. People were like confusing HTML, if it's like programming language, I think they still do, and things like that. So I'm not actually surprised that the confusion is still here today, even with such a hype term as reactive. And what we will try to do today is actually try to put some order in what reactive is and what some technologies that are using this word, what they understand under that term. So just to make it clear what we will be talking about today. We will be talking about reactive systems in context of Reactive Manifesto. Sorry for the audio. Reactive programming, we will be talking as well about reactive strings. What we'll not be talking about is reactive functional programming. This functional there is like on purpose, and to be honest, I'm not going to talk about it because there is a lot of arguments if you will start to Google it. What is really reactive functional programming, and the white paper that defines that, I really didn't have time to look into it, so I will completely skip that topic. I will not be talking about reactive developers as well. I guess we all have this, colleagues that they are just like scrolling Facebook, drinking coffee, and if you will not poke them, like, hey, there's work to do, they will not do a thing right. I mean, I'm pretty sure they are still home. They are not on this conference. They are probably still scrolling. Okay, so let's start. We'll start with reactive systems. But before we will go into what exactly is reactive system, I would like to think about some kind of change that happened in our industry. If you look back, 10, maybe 15 years. So where are we now and when we were back then? Those are like two completely separate worlds. So in terms of user base, it's like, here I found some statistics. It's like, if you look on Facebook, 2008, 100 million users, and now 1.9 billion. That's scary. I'm just waiting when Facebook will have more users than actually internet. That's, yeah. And if you think about it for a moment about user base, there is no actually upper limit. In 90s or early 2000, yeah, sure, there was internet pretty well available. Let's say mobile operators there started to provide some plans for internet in the mobile and so on and so on. But if you look on it today, I don't know, how many of you have more than one mobile phone, smartphone? Exactly. I'm pretty sure you have some tablets, you have not more than one computer. I don't know, here in Spain you have available those, Amazon is doing those magic buttons. So whenever your washing powder, for example, is running out, you don't need to do anything. You're just pressing button and magically on the next day, courier is bringing it to you. It's like, here you go. So the really upper limit is for sure not number of people on our planet. So it's like, it will grow, and it will grow like crazy. But this is not the only change that actually happened. There is more. If you think about hardware, and if you think, for example, about cloud that is widely adopted today, if you think about it 15 years ago, really, I don't think people were even imagining that. Well, some probably did, but it was like, it is still completely like a different world today. So there are a lot of changes. But the way how we develop applications, I would say it is still pretty the same. So sure, we are doing microservices and so on. But to be honest, distributed systems, they are not very new. And even though we were not doing the stuff like we are doing today, so I don't know, we at Groupon, we have, I think, around 500 microservices. Sure, it was not on that scale. But the thing is, the communication through HTTP and so on, we are doing exactly the same stuff. So we have, on one hand, really big change. On the other hand, we are still tackling problems in exactly the same as 15 years ago. And actually, this is one of the reasons why Reactive Manifesto was created. So what Reactive Manifesto is doing, it's describing, it's creating characteristic of a system that is reactive. And reactive system is the one that is responsive, because we are no longer in 90s and your users will not wait for your spinner to go there for 2 minutes. It's like currently is completely not acceptable. So this is one reason why there is Reactive Manifesto, to describe how system, like reactive system, looks like. And really, believe me, Reactive Manifesto itself is very technology agnostic, and actually you will not find very much details about how to create reactive systems. It will only describe to you how you can, how such a system looks like. Second purpose of Reactive Manifesto is to actually create a vocabulary. If you will go to an official page of Reactive Manifesto, you will find there, Reactive Manifesto is pretty small. It's like 1 page, I think, maybe 1.5. But then on the bottom, there is a glossary. You will click it, and then you have this. It's like huge dictionary of different terms and explanation, what does that mean? And the reason for that is pretty simple. Reactive Manifesto tries to create like a common dictionary for software engineers, so whenever we are talking about something in context of Reactive Manifesto, we understand each other. We don't need to go through this, oh, I'm doing REST. Oh yeah, but what is REST? Oh, it's the same as HTTP. No, that's one of the reasons. Okay, so how such a reactive system looks like according to Reactive Manifesto. At the very top, you can see responsiveness, and this is the main goal of reactive system. In order to have reactive system, you need to be resilient, which means you need to be still responsive in face of failure. Doesn't matter if it's like hardware or software failure, you still need to stay responsive. You need to be elastic, which means you need to be responsive under load, and it doesn't matter if it's like a small load or a big load, you still need to be responsive. And at the very bottom, you have their message-driven. And message-driven is kind of enabler for all the free properties that we have there. Let me just quickly start my, okay. Yeah, so what I wanna do right now, I will go quickly through each point here and talk a little bit about it. I will not really go very deep into that, and the reason is very simple for it. You can write books about it, and what's more, people are doing it. So I would need like way more than 45 minutes to cover everything. So let's try actually to look what we have in this reactive manifesto. So message-driven, let's start here because this is actually enabler, right? So reactive systems rely on asynchronous message passing to establish a boundary between components that ensure loose coupling, isolation, and location transparency. Yeah, a lot of terms. I make some of them bold so we can talk about them. There is way more, but just to give you some kind of overview, we'll go through them. So How many of you have been yesterday on the talk about reactive landscape? Okay, as far as I can see, not so many. Okay, so first things first, what is asynchronous and synchronous and non-blocking and blocking, you know? I really like the metaphor that I think Jamie Allen he's from Lightband? Oh, he was for sure, but he created. So he looked on it in terms of washing dishes, you know? So you can go and start wash your dishes, like one by one, everything is fine. That's completely synchronous. If you will call for your friend and he will come and say like, yeah, I can do that for you, you will be asynchronous. The thing is what you will do with it, because you can be asynchronous blocking or not blocking. How many of you know Java futures? Yes. So you can be like Java future. You can stand behind your friend and look like, oh, you are really doing a great job here. Please continue. You can be jerk, and futures are jerk. They are blocking. They are giving you possibility to be asynchronous and then automatically force you to to block by calling method get and wait for the result. That's exactly what they are doing. On the other hand, you can be non-blocking. You can say, cool, please wash those dishes. I will go clean my room or whatever. But you are completely free to do other things. And this is exactly how this should be. And that's exactly communication you want to have when you are thinking about reactive systems. You want to have, you know, the coupling in time. You don't want to have the synchronous request response patterns. You actually want to make a request which at some point will be handled. And then if you need response, when you will get it, you can do something with it. But in the meantime, you are completely free to do other things. That's exactly how this should look like. Event and message. So what is the difference? Because there was message passing, and as far as I remember, in the first version of a Reactive Manifesto, there was event passing, event-driven. And the difference is pretty simple. So whenever you have event and your component want to inform other components about that something happened, you are just firing up the event, and whoever is interested in that event, they will probably subscribe to some kind of queue or whatever you are using. And this is perfectly fine. The only problem is you as a producer of the event, well, that's not a problem because you are actually doing really good decoupling. But you as a producer, you have no idea who is consuming your messages. Events, sorry, no messages. When you have messages, they are always directed to somebody. They are always addressable. If you think in terms of producer and consumers, if you have like an event-driven, you are having those ephemeral consumers. You don't know who they are. You are focusing actually on addressable producers. If you are going to message-driven, then actually your focus is more on producer side and you know exactly to who you are addressing. There is a value in it. And the value is actually that consumer that you are communicating with can give you feedback. If you think about events, I mean, you can hack it. Sure, you can make a lot of different solutions for that. But it's way easier if you have messages. And to be honest, you can actually represent events as a messages. But so event will never be message. Message can be event. So actually what they did, they make it much wider in terms of what they are accepting in Reactive Manifesto, which is really cool. Location transparency. This is a pretty interesting term. Now there will be complicated question. Korba, how many of you remember this awesome guy? Yay! I see some survivors. Okay, so that's completely not about Corba, and it was called distributed transparency, I believe, right? So the idea, for those of you who never heard about it, was to actually make your remote calls look exactly as the local one. So whenever you are calling method, you had no idea if you are calling some remote procedure somewhere, or if this is just like a regular function call. No idea. So location transparency actually is tackling the problem from completely other side. So whenever you are calling your component, you are always assuming this is a remote call. And at the very first thing probably now in your mind, like, this is crazy. And of course, like, nobody is saying that every method call you should treat that way. However, whenever you have a component and they are communicating with each other, there is a really huge value in treating like communication between them in this way. But what is really important, like, in order even to do that, you need to have like a proper syntax for it. So you probably have seen already a lot of Vertex. Scala, Akka is doing a very similar thing. So whenever you are communicating with vertical or with actor, you are using exactly the same syntax. And what is really important, you have no idea if this actor or vertical, if they live exactly on the same VM or if they live anywhere. You have completely no idea. And this is great if you think about it, for multiple reasons. One reason is, for example, if you are starting a new project and your knowledge about the domain is like very limited, so potentially you see that at some point maybe you will go for microservices, but you are still not sure. Like, maybe this will be fine. If you are going in that way, think about how easy actually it is to split it. When each call is already treated as a potential remote one, you can easily split your application into smaller microservices. And this is great. Location transparency actually gives you freedom in terms of topology of your system. You can put them like whatever you want. You don't care about where they live, if this is like exactly next to you or this is like, other end of the system. Who cares? Like completely other servers in some other data center? Like, doesn't matter. And there, as a result, what you will get something that is called decoupling in space. And decoupling in space, together with decoupling in time, which you will get from asynchronously, is like very, very powerful thing. Because now, if you don't care about where your components live, if you are completely fine in having them wherever you want to have them, that makes your scalability completely not interested if you are scaling horizontally or vertically. It completely doesn't matter. Which means, actually, all the loves for example, parallel computing, you can apply there. And it's really, really great. And this is exactly where I want to go for elasticity. Elastic characteristic, which is about being responsive in face of high load. So, how many of you uses AWS? Okay, a lot. I mean, like that's pretty normal today, right? Almost everybody is using AWS. You want to have possibility to scale up and down, and that's one of the reasons why it's not called scalability but elasticity, because you don't want to only grow. You want to have possibility as well to shrink if the load is smaller. I mean, you care about your company money, right? Obvious. But how to make your system to be actually really well scalable? The problem is usually all the contention points, like shared mutable state, right? And in a perfect world, probably you want to have like one database per user. Sounds great, but that's not really something you want to have. That would be like huge waste of resources. On the other hand, you really want to minimize those contention points. So you want to have like linear scalability, right? But actually, it's like really, really hard to get there. So you always need to find what works for you. If we look on something that is called Amdahl law, and I'm really not interested in the formula, to be honest. I'm really interested in what it means. Amdahl law is saying that performance of your service is actually limited by the part of your program that needs to run synchronously, the part that you cannot actually parallelize. So if you look here, if like 95% of your program can be parallelized, at some point, like adding new threads, adding new instances, and so on, it doesn't matter. Like your performance will actually flat out. So that's very important. What Amdahl law is not taking care and it's not thinking about is communication between your components. It's like completely skipping it. And that's something that is using time of your service as well. And this is what I think a guy named Gunter, something like that, he created universal scalability law, where he added another parameter to this awesome equation here. I don't have it for the sake of simplicity and to not, make you feel bad about your services that you need to think in terms of those formulas. What he did, he added their coherence parameter. And the coherence parameter is actually the communication, the cost of communication between threads, components, and so on. You know what happened to this diagram after adding that? After some point, you do not have flat. It starts going down. So at some point, adding new components will not make you faster or will flat out. No, actually, that will downgrade your performance. So because of that, we really need to take care of a lot of things, and that's not necessarily an easy job to do. How to check elasticity. There are a lot of tools for that. Gatlink and JMeter, I think they are the most popular. So you can use them to check actually if your service is like really scaling and you want to know like how well it is scaling, if that's done automatically, semi-automatically, and so on and so on. I don't know if you are using something else. If somebody is using something else, I'm really happy to hear about it after the talk, so please just let me know. Yeah, I think those are the major one. So let's have a few words about resilient and what does that mean. Failures will happen. It's like you can be as awesome as possible, you can use really cool technologies and so on, but they will happen. Just an example, I can give you a small incident happened a few weeks ago, month ago? I don't know, it was some time ago. One of our legacy systems, it was losing just Redis as a cache. Nothing really fancy. But because operational department, they were like trying to, clean Redis instances that we are not using, and there was like plenty of them, they accidentally removed one more. Happens. System was like pretty old. Nobody was really developing it. It was just there running. So as you can imagine, we were pretty surprised. Not very resilient system. But how to get actually resilience? Three very important things about resilience is replication, isolation, and delegation. If you think about replication, that's obvious. But replication is not only about databases. Of course, you as a company, your company probably really value the data that you own, and probably it's like you already take care of replication and so on. You don't want to lose it. But what replication here is about is not only about databases, it's as well about services, about load balancers, and so on. This is about like really full stack replication. Because if your data center will go down, what then you will do? And I know that sounds funny, but a few months ago there was Amazon S3 actually failure, right? I don't know if you checked that, but Netflix actually, they almost didn't notice. They were like, oh, something happened. Amazing. So, sure, I know yesterday there was a talk who was actually advocating that you are not Netflix and you are not having those problems. Well, I would argue that actually failures, they are not Netflix-specific problems. Isolation. Okay, so you need to isolate your services. You don't want to have this domino, you know, when one is failing, all others are failing. This is exactly the place where you should put like timeouts. This is exactly the place where you should put circuit breakers. But not only that, this is as well about replication and giving services that are calling your service possibility to have some kind of, you know, fallback, like some kind of, I don't know, cache or whatever that they can use when your service is not up and running. And of course, there are a lot of problems then. Again, it's like if you are replicating the services, you need to know in what setup are you using, where is the master, where do you, if you can have like multiple masters, and so on and so on. And this is again actually like very use case specific. There is not one single bullet that will work for everybody. You need to figure it out on your own. Delegation. Delegation is actually a concept that is about having kind of monitoring on each of your component, but not only as if it's alive, actually with power, for example, to restart it. Because if you will have a failure in terms of hardware, the instance will not heal itself. It needs to delegate task to somebody else. How many of you are doing health checks? Yay. How many of you have seen a service that is responding with 200 for health checks, but it still doesn't work? I did. Exactly. Oh, sorry. My God. So that happens, and that's not the perfect way to do it. If we would, for example, enrich the health check with information about exception rate and so on, then maybe, yeah, sure, but like the health check on its own, it's like very, very simple way to actually monitor your liveness of your application, and it not necessarily always work. So how to check resilience of your system? Chaos Monkey. Pretty crazy tool. Netflix is using it on production. They are actually like shutting down from time to time some services on production, some databases, maybe sometimes data center. You know, just pure fun and see how it works. If it still works and nobody noticed, it's pretty good. It's pretty good. They have more components like that, but this one in particular is like very, very useful. Okay, let's try to wrap it up about what we talk about. Oh, really? Okay, I need to speed up a bit. So we were talking about reactive systems, that the most important characteristic for them is actually being responsive, and the way to do it is actually to stay responsive under load and failures. And the enabler for that is message-driven system with asynchronous and non-blocking communication. So actually what I did right now, I just wrap up in one sentence everything that I was speaking about for the last 20 minutes. Amazing, right? Pretty cool. Okay, if you want to have like more details, not only this abstract things about how it looks like, but you really want to know how to do it, I can recommend Reactive Design Pattern book by Roland Kuhn. His like the book is like really, really good. It's pretty new. I think it was published this year. Yeah, so that's one of the reasons why I think everybody should read this book. A lot of really great content there. The other reason is because actually Mr. Roland is like a really cool guy. So yeah, I think it's worth to give it a shot, this book. It's really cool. Okay, let's quickly go to reactive programming because we have like 15 minutes. It's really, really hard to actually find a good definition of reactive programming. I don't know, I was reading like so many of them, and Wikipedia, of course, which is like the first source where everybody is searching for definitions and so on. The definition there is like pretty bad, actually, like regular imperative programming you can put there as well. It doesn't make much sense. So I ended up with this definition, which I think is pretty okay. It comes from a blog post by Jonas Bonner and Victor Klang. So basically, reactive programming is like a subset of asynchronous programming where you are more focused. Like every next step is a result of the data available in the previous one. This is still pretty general, so we will take a look on an example. And please do not compare it in like, oh, but you know, in imperative way, this is better or this is worse, and so on and so on. There is like no better, worse. This is like a little bit different way of thinking about how you are structurizing your program. So let's take a look. This is just some example created on the fly. And the easiest way to actually do reactive programming in Java, if you want to do it, is completable futures. They are actually giving you everything. Well, they are not giving you everything that you need, but this is really the easiest way to achieve it. So we have some user data future, and then whenever the data from there will come, we are calling, I think I have pointer here, amazing. Then we are calling then compose, and this function will be called. This function is doing another, it's creating another completable future. This is by get contact, get preference. And then when both of them will be done, then this function is called. And so on and so on. You can add a lot of different stuff. The thing is, first of all, you do not have a single thread of execution here, of course. You can actually, probably all those methods, they are scheduling all the processing on completely different threads and so on, so you have complete freedom here. As I said, the important part about it is actually each next step is a result of data available in the previous one. So if you, for example, would have exception or something like that, probably you can just like skip some steps and appear in step that is handling exceptions, you know. So that's one of the reasons why, for example, reactive programming is really hard to debug if you will start playing with it. And I guess nobody really likes to work with completable futures. Do we have some lovers of completable futures here? Oh, really? Okay, cool. Okay, I don't like it. The reason for that is pretty simple. They are very limited. They are eager. It's, you cannot easily make them lazy. They are limited in terms of they are always returning like one item, so you cannot return multiple of them. It's really hard if you want to create like infinite stream of data or something like that. It just doesn't fit. So one fits there and give you something better is reactive streams. And reactive streams are initiatives to provide you like a really, really standard way of treating asynchronous streams together with back pressure. And the word back pressure actually appears in Reactive Manifesto as well. We will get there in a moment because it's really worth to explain what does that mean. But before that, let's take a look how the standard for reactive streams actually looks like. 4 interfaces. Feel free to implement them. And you have your own implementation of reactive streams. Of course, it will not be that easy because reactive streams, they come with TCK, Technology Compatibility Tool, TC Kit, exactly. So you will have like bunch of tests that actually your implementation needs to pass in order to be like a really fully legal reactive streams component, you know. But you are really free to do that. Of course, you do not have to do it. There are plenty of implementations. Probably the most important and famous is RxJava, which since version 2.0 is actually implementing reactive streams. If you are Scala guys, do we have Scala guys here? Some Scala guys. Okay, first of all, Scala guys, usually they know a lot about reactive systems. So if you have questions, I'm not Scala guys, you should ask them. Second of all, reactive streams in Scala, usually people are using Akka streams, I think. We had yesterday presentation about it. There is as well Reactor from Pivotal. So if you are using Spring Stack, it's there. Okay, but what's with the back pressure? So the concept of back pressure is actually pretty simple. In a perfect world, whenever you are having consumer and producer, they are working almost on the same speed, right? So you have no problem. If producer is slower than consumer, that's not a problem as well for you. You're pretty safe. The question is, what will happen if the producer actually will be producing faster than the consumer can consume? Well, you can do a lot of things. You can drop some messages, for example, because you will say like, yeah, that's too much for me. And for some systems, like, I don't know, trading and so on, that's not a big deal if they will like skip just, especially if it's, I don't know, Yahoo or not very dedicated to trading system. If they will skip some updates, that's probably completely fine. But if this is like a very critical in terms of time system, that's probably not a good idea. You can expand your queue, but that will not work as well. So how reactive streams are tackling this problem, they are giving consumer possibility to actually request a specific number of items. And if you think about it, that's pretty great, because here you have push model. Here, actually, you have push-pull, because you can decide. If you want to pull, you can request 5 elements from time to time, and that's cool. But if you're pretty sure you can keep up with the producer, you can say, give me integer.max. Hit it, and you will have push again. So this is a really, really cool concept, how to deal with that. And mostly that's exactly what reactive streams are about. Of course, your producer needs to respect back pressure. If it does not, like users in front of the browser, sorry, it doesn't apply. Okay. Can I use reactive streams to implement reactive system? Very good question. Some people think that adding RxJava to their system actually will make their system reactive. No, will not. RxJava, of course, or other reactive streams implementation, they will help you, but they will not make your system reactive. Reactive is like a much bigger thing, as we talked just a few minutes ago. What it will help you with asynchronous processing. It will give you back pressure. It will give you decoupling in time. By any means, they will not give you decoupling in space, because the reactive streams, like RxJava or Reactor and so on, there is no way that you will actually transmit message between streams on different machines. Of course, you can use some libraries that will give you that possibility, but you will not get it like out of the box just with adding Akka streams. Well, Akka stream? No, I don't think so. For sure, RxJava will not do that for you. Okay, I think this is all in terms of reactive streams. There are still things like reactive application. Probably you heard about it. Some people are talking about reactive applications and what they are. Play framework, anybody? No Play framework today, okay. So for example, Play framework, they are claiming that they let you build reactive application and so on. And what they really mean that usually they are actually really using reactive programming in a way that will boost performance of your application. They are usually not request per thread per request, but they are more like thread per core. And they are assuming that everything will really go in an asynchronous and non-blocking way. So that's more or less what they are understand under term, reactive. And for sure, you will find other definition of it. So reactive sockets, for example, they are trying to deal with communication, and they are, of course, referencing to Reactive Manifesto, but they are explicitly saying that they are just trying to solve some set of problems that, when implementing reactive system, you can actually see. So, like I said, a lot of different definitions of the word reactive. Okay, so I think we covered more or less everything. And two things I really want you to get from this presentation are. One, I want actually you to be even more confused now. Because whenever you will see a library or framework that is claiming that it's reactive, you will now hopefully understand that that's not so easy, and you will need to dig to check what those guys understand under term reactive. That's very important. And the second thing, because we talk about reactive systems, and it would be a shame not to use this opportunity to actually make it kind of output of this talk, because this is like a very powerful concept. When you will get back to work tomorrow, probably, and you will grab your first coffee. I'm not working before first coffee, sorry. And you will grab your first coffee. Think about the system, and I really couldn't care less about what technology you are using. Really. What is important, think about your system and if it's responsive in terms of resilience and scalability, elasticity, sorry. And if it's not, try to figure out why and how you can improve. How to make your system actually move a bit into reactive direction. That's exactly what I did. I looked through the system, and it helped me a lot, helped me understand it, and helped me grow as a developer. And if it worked for me, I think why it cannot work for you, right? Thank you very much. By the way, we are hiring, Groupon. Everybody's hiring. I will just put it here. If anybody thinking about moving to Berlin, I'm super happy to talk about it. A company will help here and there. Just find me, I will be hanging around. Okay, question and answers.
Isn't it just moving the problem elsewhere? This is how I see back pressure. So you don't have a problem on your consumer, but then you have a queue on your producer.
Not necessarily. I mean, that really depends. So if you do not persist like jobs that you need to do, and you are like fully volatile, and you are really, just pushing it there, or you need to keep it in memory and so on. Yes, sure, this is a problem, and I'm not saying that this will solve all the possible problems. But what is important here is actually that in reactive systems, the services, they really need to take no as a response, as a possible response from the service that they are communicating with. And because of that, yeah, sure, you need to be able to retrigger the request that you are making. So yes, it is for some use cases pushing problem into just like from consumer to producer side, but there is like a really bunch of like use cases where you can really benefit from it. But yeah, sure, that's completely not a silver bullet. It will not solve everything. You cannot apply it everywhere. That's true. Anyone else? No? Okay then. Thank you very much. Have a great time. If anybody has some question like in private want to ask, I will be somewhere around, so feel free to just grab me.